So welcome back. We're continuing our work on calculating exact forms using algebra of trigonometry. Last lesson we looked at identifying what the exact forms when we had things such like cos x equals half I would get. I'd look at this and say, well, my positive values, positive for 1 and 4, these will be my two possible answers, pi on 3 and 5 pi on 3. However, there are changes that occur to your period interval as well. So for instance, if we had, let's go back a little bit, if we had y equals sine equals sine x, we know we have a period between 0 and 2 pi. Now if we had y equals sine 2x, then we can work out that period by doing 2 pi divided by 2 to give me pi. However, when it comes to calculating with exact values, this too has a different approach. What it does is it multiplies your x value in the interval and expands our interval itself out. So for instance, 0 to x to 2 pi would be a fit for y equals sine x. However, if I had y equals sine 2x, then I have to rewrite this as 0 is less than or equal to 2x, which is less than or equal to 4 pi. And the reason why is this here is one whole period. This here, if I calculated this and worked out what my period is, well, 2 pi divided by 2 just gives me pi. To fit into this range here, I'd have to multiply this by 2, so therefore I get a full range. So this is only going to be half that singular period. So therefore, what I do in this case is I just times whatever the value is in front of x, remember your b value, by the x in here, and that also multiplies my ending interval. So for instance, if I had y is equal to sine 3x, well, the new interval here would become y is less than or equal to 3x, which is less than or equal to 2 times 3, 6 pi. Or if I had y is equal to sine half x, then this here is the same as doing 0 is less than or equal to x on 2, which is less than or equal to pi. So when we're looking at working with unit circles, we're looking at this case saying, well, if we have x by itself, we're only going around a unit circle once. If it's 2, it means well, you're going around that unit circle twice, and you're going to be adding pi on to any values you've already found in that first revolution. If it was y equals sine 3x, then you're going to add you go around the unit circle once, you then add 2 pi to get to that point again, and then you add another 2 pi to get to that point. So effectively you're adding on 4 pi onto your 6 point here. And here you only go to that halfway point. So let's just see how this works in an example. So for instance, let's write up an equation. So we've got sine, what have I got here? Sine 2x is equal to negative half. Here is our question. Okay? So, the first thing we're going to do is, as normal, we're going to be looking at this and saying, well, I know that this here is my range, or my interval, from 0 to 2 pi. However, I want to multiply this by 2. So my new interval now will be 0 is less than or equal to 2x, which is less than or equal to 4 pi. So basically that means I'm going around that unit circle twice. And we're going to get to that in a second to explain how that works. Let's now start solving this question like we did for the previous questions. So the first thing we notice is that half is a negative value. Now, because it's negative, that means that sine is going to be negative as well. So where is sine negative? Well, sine's negative in quadrant 3 and quadrant 4. So we can say here, in quadrant 3 and quadrant 4. So in quadrant 3, and we've got these here, we're looking at sine negative half. We've got 1, 2, 3. So in quadrant 3, it's going to be 7 pi on 6. Okay? And then in quadrant 4, 1, 2, 3, 4, it's going to be 11 pi on 6. Now, let's just draw up a unit circle here, because this is where it gets a little bit tricky. We've worked out that we've got 7 pi on 6 here and 11 pi on 6 here. And we've done one revolution. We've started from 0, we've come around, and we said, well, this is where sine is equal to negative half here, and this is where sine is equal to negative half. And I come back around and I've done one revolution of 2 pi. But because I'm going from 0 to 4 pi, I have to go around again, and I have to add that 2 pi revolution. I'll get to this. And I add 2 pi to this here as well. So once around is 2 pi, and once I come back around again, I've already gone 2 pi, I'm going another further 2 pi onto this point. So that now leads us to looking at something that looks like this. We've got sine, well, we don't have sine now, we've got 2x is equal to pi on 7 pi on 6 or 11 pi on 6. But because we're going around twice, this is actually going to be equal to 7 pi on 6 plus 7 pi on 6 plus 2 pi. Now we can work that out by saying, okay, well, if I put this over by 6 and times that by 6, I get 12 pi plus 7, which is 19 pi. But I'm not going to put that in this, I'm just going to put 11 pi on 6. The next one here is then going to be, well, if I then add, so if we put this working out, where we'll put the working out? Let's put the working out just here. 7 pi on 6 plus 2 pi, because I've done that second revolution. It's just a matter of using your understanding of fractions. So therefore, we get 7 pi on 6 plus 12 pi on 6. So therefore, 7 pi on 6 plus 12 pi on 6 is 19 pi on 6. And then we can do the same thing here. 11 pi on 6 plus 2 pi on 6, which is the same as 12 pi on 6, is 23 pi on 6. So therefore, we've now worked out from 0 to 4 pi that we have 4 coordinates. However, we're solving for x. So in order to solve for x, we have to get rid of this 2. So how do I divide by 2? I can multiply by a fraction. So if I multiply everything here by a half, the only thing that changes would be my denominator. So therefore, x would become 7 pi on 12 or 11 pi on 12 or 23 pi on 12, oh, 19 pi on 12, I missed the 19, or 23 pi on 12. And this would be the 4 possible answers for when we have sine 2x is equal to negative half. We can either get 7 pi on 12, 11 pi on 12, 19 pi on 12, or 23 pi on 12. And the reason why these numbers are greater than what we have over here is because our interval now is increased up to 4 pi because of the 2 here in the x. So we go around once and we get those values, and then we go around another 2 pi to get those values. If this was 3, then I go around another 3 pi and I get 2 different answers on this. So this here would be plus 3 pi. And if I went up to 8 pi plus 4 pi, and so on. So this is the effect of changing that period interval. So by changing your period interval, if I had that sine equals 2x equals half, instead of having 0 is less than equal to x to less than equal to 2 pi, it now is 0 is less than 2x, which is less than equal to 4 pi because I multiply those through. Alright, I'll see you in the next one.